So this question, if you recall, it asked to find velocity of point A. So we know position of XA is equal to X, like as this diagram shows. And its velocity is just simply derivative of X with time. And its acceleration is just derivative of velocity, which is X double dot. Okay? So this is something that we know. Now, the key here is to find the relation between this X, basically, and theta. And this is something that, again, most of you got it right. It's easy. You have a triangle, and you know this X and theta, how they are related, right? Since R is constant, simply X is equal to R sine theta. And if you know this, then the rest is just taking derivative, which I'm sure most of you know how to do it. And derivative of X double dot is going to be derivative of this guy, which is R theta double dot cosine theta minus R theta dot square sine theta. Don't forget, derivative of cosine theta is minus sine theta. And then derivative of theta is theta dot. We already have one theta dot, so it's going to be R theta dot square. So we have theta double dot, right? Question gave it to us. It is 3. And but we don't know theta dot. Theta dot at 45 degree. But we have a nice formula which we can figure it out, all right? So we know that the formula theta dot is equal to theta double dot d theta. And if you just simply do the integral, so what you're going to get is theta dot, let's say from theta dot 0 to theta dot 1, theta dot 1 squared minus theta dot 0 squared is equal to 2 theta double dot, because it's constant, right? This is constant. It is equal to 3. And here, delta theta, right? Because we are writing from theta 0 to theta. And, or simply you can just use the formula that we developed before. Omega 2 squared minus omega 0 is equal to 2 alpha delta theta, which basically these two are the same. It's just instead of theta dot and theta double dot, we replace it with omega and alpha. So we want everything at theta equal to 45 degree. All right, so then this delta theta is pi over 4. I have the information for this guy. This is 2 when the speed starts. And I have alpha, right? It's 3. So it means I have theta dot, and all I need to do, I just replace them here. Okay, so do you guys have any question for that? But the key things to start is this, connecting these things. Keep in mind, as I said in this course, we solve several problems. You just need to find out from geometry how things are connected, which, like in this example, it's super easy. Okay. So if there is no question for that, I'm going to post the detailed solution on Canvas, which you can check it later. Question 2, I'm not going to solve it because it is exactly similar to what you saw in the class during the lecture. This is exactly similar to the problem when the boy slide on a slider down, right? And since you are on a circular motion, you have 2 acceleration. One is the normal acceleration and one is the tangential acceleration. An, which is r theta dot squared, and at, which is r theta double dot. This is your acceleration. And just out of laziness, I draw everything on one diagram here. We have weight and we have the normal force. So this is N and this is mg. We have everything that we want. This angle is theta, right? All we need to do is just writing that sum of the forces is in N is MAN and sum of the forces in T, MAT, the Newton's second law. And then the rest is just math that you can easily figure it out. A key formula here again is to find the relation between theta dot and theta double dot, which is basically this formula. All right. Any question for this one, guys? Are we good? Okay. And then the last one. This one is a bit tricky, but some of you got it right, which is good. Similar to question one, you just need to find, connect these parameters together. It's just the geometry that you need to figure out. But as a general rule, in a question, which we will see like in this course a lot, whenever you see a triangle, let's say in this case, we have a triangle here. If I connect O1, O2, then P, and then O2 to P. There is a triangle, but this triangle is not gonna stay a right triangle, maybe at this moment, right? The moment that things start rotating, theta is changing, and let's call this angle beta. Beta is changing, and also X is changing. The only things that is constant here is B. B is not changing, right? And also R is not changing because the distance between this P and O1 is constant. I put also a link for you, maybe some of you watch it during the exam. It was a short link which shows this mechanism. It's a famous mechanism called Geneva wheel. It's used in Geneva watches, maybe that's why, or Geneva clocks, maybe that's why they call it Geneva. And as you can imagine, for every complete revolution of the wheel, A, right, it's just going to be a quarter, 90-degree revolution for the one on the right. So we call it a driver, the one on the left, because it drives everything. The motor is connected to that. And the one on the right, the one on the left, we call it the driver. And the one on the right, we call it a follower, because it follows wherever the other one goes. Okay? So what I was trying to say is whenever you see, let me write it here. Whenever you see a triangle, I'm sure you remember it from your math course or from maybe trigonometry if you took it somewhere in high school. Let's say if I have A, B, C, a general triangle, and let's call this angle alpha. So it is in front of A, we call it alpha. Let's call this guy maybe beta, and let's call this guy gamma, okay? Like a general. It has nothing to do with the problem that you're solving. In general, so there are two laws. One is the law of sines. The law of sines is telling us that basically there is a relation between these three parameters. If I write A, B, C, this is the way that I memorize it. So if I write A, B, C, and then for denominator, we're going to have sine of alpha, sine of whatever it is in front of that side of that triangle. So this one is going to be sine beta, and this one is going to be sine gamma. Okay, this is law of sine. And we have another law, which is called law of cosine, which is, again, something that maybe you are more familiar. Let's say for side C, I can write C squared is equal to A squared, B squared, 2AB cosine gamma. So please pay attention. C, the angle in front of C is gamma, so it is cosine gamma. Okay? And you can test this formula. If you put gamma equal to 90, it becomes 0 this side, and this is the familiar Pythagorean formula, right? That you all know. So keep these two relation handy, and whenever you see, like in this course or other courses, you see a triangle, you can relate these things together. Okay, like here in this question, for example, if the question asks us something about x, it asks us that how the speed of p is changing relative to O2. Like we want to know how this x is changing, because see, as this thing is moving, this point P is getting closer and closer to point O2. And if somebody asks us how this point P is changing with O2, what is its velocity? So we say, okay, wait, I can relate this x somehow to other parameters, like a square root of r, a square root of b, and minus 2rb cosine theta. So if I know how theta is changing, then simply I can figure out how x is changing. Okay? But this question didn't ask us anything about x. It just wants to know what is beta. So I need to relate beta to theta. Maybe a better formula is this sine relation, right? Let's see how we can use it. Again, I'm trying to avoid x. If I try to avoid x, can I write, let's say, if I call this angle, we have a triangle, so this one is going to be 180 minus theta plus beta. So can I write, let me write it like that. So I like to involve only r and b, because I know they are constant and I have the value. So r is going to be sine beta, and b, what is in front of it? It's sine 180 minus theta plus beta, which we can simplify. It is going to be r sine beta is equal to b sine theta plus beta. So sort of the problem solved, because after this is just substituting this value for r and b, which make it super easy. Like r is 50 square root of 2 and b is 100, right? You can simplify everything and then take the derivative. All you need to do is just taking the derivative. Let me quickly do that. If I have r 50 square root of 2 and b 100, right? So I can simplify these things. And what do I get? I get 2 sine beta is equal to, or the square root of sine beta is equal to sine theta plus beta. And this is my key formula, and all I need to do is just substitute this value, because we want to know at theta equal to 0, 15 degree and 45 degree, what's going on with beta dot. And we take the derivative and then problem solve. Okay, so please check the detailed solution later. And if you have question and it's not clear, let me know. And you can ask now if you cannot follow the solution. I'm going to check chat to see if there is any question in the chat. Oh, the chat says it is incorrect. Let me. It should be. It should change now, guys. Can you try chat just to make sure that it goes to everybody? Okay, now it's working. Okay, so I'm going to check the chat again. So no, if you use a different method and you got the answer, no problem. So you may use a totally different method for solving this, which in the next chapter you learn how to solve this one without using the geometry, which is a more difficult solution, and that's okay. But if you use like a different approach, maybe you search for X, that's totally fine. Even if you don't get to the final answer, but still you will get credit for partially for your solution, even if your solution, let's say, doesn't lead to a right answer at the end. Okay, so with that, so again, for those of you who arrived late, your grade will be posted today. If you think there is a mistake, please let your TA knows. He marked them, and he will post your grade today. If you are unhappy with your grade, don't worry. If you do better in your second midterm, I basically decrease the weight for the first one, for this one to half, and I add it to the second midterm. Time zone issue, I understand some people are in places that maybe the exam is midnight. So we will decide closer to the midterm 2. I'm okay to let the exam be open for 12 hours. So you can take it during the time that you want. Except with that, I'm not going to do any invigilation, and I'm just going to trust you and going based on honor system. Okay. So let me switch the document to something else. Right. But before we get to the lecture today, do you guys have any question or anything related to the exam or in general? Or any basically feedback or anything that you think that if we do differently for the lectures, it's going to be better? For example, if it is too fast, the pace is too fast, too slow. Something that you should know, so far it was mainly a review, but a different review. But the topics, at least, they were something that you are familiar with, including the today lecture. But as of next lecture, the topics are going to be new, but still the same concept, except for considering a dot moving. On those mechanisms, you just see one point P is moving. Still, there was a mechanism. As of next lecture, we will consider a rigid body moving, so which we need to consider other things as well. I'm going to consider chat. Yeah, no problem. So the time zone is going to be considered for your second midterm. Okay, I will find the best mechanism that you guys be happy. And all right, so let's get into the today lecture. This is part of we are continuing on lecture 7, 8, and I just said +9, which is lecture today. So in this lecture, we said there are 3 methods. We discuss Newton law, and then we get to work and energy and impulse and momentum, which in the very first slide, I just showed you the next 2 methods. They are nothing new. They are just the same basically formula derived from the same formula F equal to ma, which you saw them, right? And then it leads to the work and energy formula, which we said total energy, we have different form of energy. We have kinetic energy when a mass is moving. We have gravity, which is like a potential energy, and elastic energy when we have a spring. There are different sort of energy like magnetic energy, energy from heat. But in this course, we just consider these three forms. We show them by T for kinetic energy, U for potential energy, and in order not to confuse V with velocity, we show VE stand for elastic energy when we have a spring. There are two types of spring: a linear spring, half of kx squared is its energy, x is the deformation or deflection. And if you have a torsional spring, which if you notice around you, maybe some mechanism with a hinge, they have this torsional spring. The energy is half of kt theta squared. Again, we put a t here, not to confuse this k with the previous k, just t for a torsion spring. And the law of conservation of work and energy says that whatever energy you have at point 1, plus if you do some work, some external load, the work from 1 to 2 gets you to the energy at point 2. If there is no work, then E1 is equal to E2. If there is no external load, E1 is equal to E2. And then we talk about power. Power, it's how fast we are getting the work done. So the parameter of times come to place, and then we define power as force multiplied by velocity. And also we discuss the unit here, which please take a review, review them. And we solve some problems. And today let's try to solve one example, example 4, together. If you guys could follow this example, it has lots of details in it, then you're sure that you understand this topic well. Okay? So I'll let you guys to read this example. I'm going to do the same, and then we will solve it together. Okay, let's see what we have here. And as always, your first task is to figure out how things are moving and try to relate them and see if you can find any relation between them. So this one is easy. I can see there is like this maybe bar, which the question says this OA has like lightweight for now. But later, this thing is going to have a weight, like this bar OA. But for now, it is lightweight, no mass. A has a mass, it is MA. Then we have this weight B, MB. We have the pulley, and then we have this KT, a torsional spring. So we release everything from rest. So B, because maybe B is bigger than A, is going to push everything down. And we want to know when these things coming down, let's say everything's come down here. We want to find out like basically the speed of these A, it just says before it touch the ground, because the moment it touch the ground, things become complicated. There are forces from ground. We just want to know everything's at the moment just before it touch the ground. But we estimate that it's going to be horizontal. Okay, so this is the question, and this is position 1, and this is position 2. Of course, when these things is coming down, we know that this mass also is coming down. So write that, right? So let's see how I can approach this question. If, let's say this length is L2, definitely this length has to be L2. Look at the geometry, this point C, move on a circle and come to this point, right? So then if OC is L over 2, then let's call it OD has to be L over 2. So immediately we can then figure out the length of this guy is going to be L square root of 2L. If I know the length for this triangle, so I know the length over here. Any question in the chat? So question is, can we say the mass is going to be further down? So this, don't get confused by this S here. Let me get rid of that. So this S is the name of this, basically it's this string, it's called S. We don't know the length of that, but we can find the relation between L2, L2. So this length, CD is basically from this triangle, we know that, okay? CD is gonna be a square root of 2L divided by 2, which is like this guy, okay? So up to this point, we have this information. There's something else that we need to know, which again, I'm sure you recall from physics. For the pulleys, let's say, if I have a pulley like this, and this pulley, let's say, it is fixed to a ceiling. So if I have a rope passing through that, so we know if somebody moves these things X, then this side is going to move up the same amount, X, right? But the same setup, if I have it like this is my pulley, and let's say I fix one side of the rope here. Now we know if we move this point, let's say X, do you guys remember from physics how much this guy is gonna move up? You can type it in the chat. Yep, X divided by 2, exactly. So if this thing moved by X, this one is gonna be X over 2. And you know the reason from geometry, I'm just gonna draw it bigger. So if, let's say, okay, so let's say if I have this guy here, and this is the rope coming down, and now I would say if I move up by X, then the triangle that I have over here, right? Using this triangle, if this guy is X, the center is going to be half of X. Okay, so like because of this rule, we will say that if we move one side X, the center is going to move half of X. And this is based on, again, geometry. Because for a moment, we can assume this point is fixed, and we are just pushing X a little, maybe 1 millimeter, then the center is going to move half a millimeter. So this is the information that we know from the past. Let's see if we can use this information here. I'm going to write down whatever energy I have in point 1, and then whatever energy that I have in point 2. And I don't have any work done on this system. Work is 0 because I don't have any external load, no forces here. Like the system is on its own. We release it and it moves to a position 2. So E1 has to be equal to E2. And then based on that, I can solve my problem. Whenever you use energy method, don't forget you need to set a reference. It can be anywhere, it's up to you. I prefer to put my reference here. And this is basically for potential energy. Now I compare everything with this point, like with this line reference. How much energy do I have at point A? Always remember, like back of your mind, E has this formula: kinetic energy, potential energy, and elastic energy. Okay, so when I'm position 1, nothing is moving because the question told us that we release everything from the rest. So no T then. Potential energy, yes, A has potential energy. It is MAGL. And since it is above the reference line, it is positive. What about B? Well, it has also potential energy, but we don't know where it is. So let's call this distance H. Okay, let's call this distance H. And of course, the mass B is not at this point, but for now, because this distance always is going to be constant, right? This is not moving. We don't care about this constant. Just let's, for now, not think about this constant. Or in another way, we can think of all this mass B to be a point mass at the center of this pulley, okay? Or you can just put a name for it. That's fine. So then I have how much energy for B? MB, G, H. This is all energy that I have when I'm at position 1. Do you guys agree with that? I'm going to chat to make sure that everybody's agree. Yep, that's the potential energy for mass B. That's correct. Now, and nothing is moving, so this is all we have. Let's write down carefully energy for point 2. Okay. When I'm getting to point 2, first of all, this mass A, it's coming to the reference, nothing then. I'm happy with that. But what about mass B? Mass B is going to move down. How much? This is where we need to be careful. I'm just going to let you guys to think how much B is going to come down. So I'm going to write down MB, G, and your task is to find out how much this point basically is moving down. So let's think about it for a moment. If this point C come to point D, it means the length of the rope is going to increase this amount, right? Do you guys agree? Because we found the length of this rope from C to D to be this amount. Now everything's coming down. So we just said whatever one side of this pulley is changing, the center is going to be half of that. So then do you guys agree that this distance is going to be half of CD? Let me write down CD. Or it's going to be half of the square root of 2L. So then can I write down here that my new energy here is going to be H plus the square root of 2 for L? Please take a look and check to make sure that I haven't done any mistake. Seems right, right? So if this point C come down this amount, the square root of 2 divided by 2L, then the center is going to be half of that. That amount of half plus h is going to be the distance from the reference. Remember, this is our reference, and we wanted to know like the total distance, basically, which is going to be h plus the square root of 2 for L. Okay. So if we are okay with the potential energy, gravitational potential energy, let's take care of the spring. So we have a spring here sitting there. Now it rotates 90 degrees. Potential energy for a spring is always positive, and direction doesn't matter. It's always positive. So half of kT, how much? 90 degrees. In this course, always radian square. If by mistake you put here 90, you can imagine it's going to be a very, very large number, and your whole solution is wrong. The way that the formula was developed is that we want radian here. So if we rotate 90 degrees, this is the amount of energy it's going to saved into this spring. So this is for our potential energy. Now everything has a speed, right? When these things coming down, they have a speed. A has a speed, B has a speed. And remember, guys, the question says the moment just before A touches the ground, because the moment it touches the ground, the speed is going to be 0. But we want to know just a millisecond before touching the ground, what was its speed, okay? So I need to write then here half of MA VA squared, half of MB VB squared. So this is our energy, like the formula for E1. And this is our formula for E2, which is a lot of terms, right? It has potential energy, it has elastic energy, and it has kinetic energy. So we can just solve this problem, except we need to find a relation between VA and VB, because this equation assume that the question gave us all the information, the mass, the distance, and everything, except we don't know what is the velocity of A and what is the velocity of B. Now my task is finding the relation between these two guys. Then the problem will be solved, which I'm going to let you guys to see if we can figure out the relation between them. And while you are thinking about it, I'm going to check chat. Yeah. So yeah, E1 is going to be equal to E2. Why? Because remember the law of conservation of energy? What did we say? We said if there is no external load, it means there is not going to be any work. So the work is going to be 0 then your energy is going to be the same, right? We don't have any external load here. So any idea how VA and VB are related? I'll just give you a hint. Let's say when this link is moving, I'm just going to exaggerate here. What is the velocity of point A? Let's call it VA. Then what will be the velocity of point C? Like VC here. Can I write down that? Can I write down that VA or VC is half of VA? Again, look at this triangle. This is like in this right triangle, if this is L divided by 2, this is L divided by 2, whatever speed of point A is, point C has half of its speed. Okay? And we know the speed of point C is somehow related to basically to this string, to this rope, right? And also we found something else. We found that, like based on the pulley rules, whatever the speed of this guy is, let's call it VB, right? It is half of the speed of this string. VC, right? Whatever the speed of this point is, this is going to be half of that speed. So can I then write down that VB is half of VC? Let's take a look and make sure that this is right. So the first part seems straightforward. We have a triangle. In this triangle, this point C is halfway through between O and A. So whatever the amount of point A is moving, point C is going to move half of it. And also point C is attached to this string. And we just discussed this, that this string, whatever amount it moves, the center of this pulley is going to move half of it. So I can then write VB is half of VC. So somehow we could relate VA and VB together, right? If you get rid of VC, I can just write down VB is a quarter of VA. And now in this question, if we have the information for the length, for the mass of A, mass of B, then the problem is going to be solved. And we are not worried about H, because H, we are going to get rid of H from these two equations, from left and right. All right? So take a moment, write your notes, and if you have any question, please ask me. So I'm going to write also down here. So we need this information. We need to know mass A, mass B, and L, and also KT. This is all we need. Which we assume is going to be given by the problem, basically. It will be given by the problem. Okay, so try to review this question again. It's one important question. If you understand how to solve it, it has everything. It has a spring, it has pulley, like a rotating motion and linear motion, then you should be okay for energy method. Let me quickly check the chat. Nothing there. Okay, good. And I let you guys to think about this problem. I post a solution, but before checking my solution, try to see if you can solve it yourself. Let's read it quickly, and then I'm not going to solve it. I'm going to let you guys think about it and solve it. So let's say what we have on a table, we put a chain, and a portion of this chain is hanging. And maybe this portion that is hanging is heavy, and then everything slides down because we don't have any friction. So we want to know the velocity of this chain at the moment that it leaves the table, right? When it leaves the table, so the whole mass, the whole chain is going to be like in a vertical position, right? So it's going to be, let's assume this is the chain. Right? Everything is going to be here. We want to know its velocity. Of course, not moving to the left, but I just draw it for this moment. So use energy method and try to solve it. Just a hint, in general, let's say if you have maybe a bar, let's say you have a bar on, let's say, ground. And let's say this bar has a mass of m and length of L. How much is its potential energy? It's a question for you. Any idea? Let me check the chat. Yes, you guys are right. It's half of mgh. So we can assume that the whole mass is gathered sort of at the center here. So which we call it center of mass, or we show it by G. So then our energy is going to be mg half of L. So we can use the same concept for this guy, for this chain. So you need to calculate this energy when we are sort of like in this position, like this is position 1, that this length, right, is just h, and then position 2, where the whole thing is going to be L. Okay, I guess you got the idea how you can solve.